Okay, so let's finish what we were doing. Battery was over in the middle, so let me show you what I did so that I can just upload this one as well as continuous of the previous one. So I think we were here. So I just muttered the math. I approximated. So you remember this, right? Yeah. So I approximated this as one. I approximated this as one, and these terms combined give me this. Okay, okay. I didn't approximate this as 1, I approximated this as 1 by e power n. Yeah, I approximated it like that. And so this is what I will get. And yep, this is it. Maths butchered successfully, and I got the result successfully. So, however, I got it. So, let's compare the result. So, the claim is if I have a binomial distribution, which looks like this, of course. Uh, and I have another a function, and I write something like this. So average of this binomial distribution is np. So if I write np power x divided by x factorial e power minus np, these two should match, right, for a large n. And you can see how nicely it matches. Like, this is what I got for 1000 trials. And for 1000 trials, probability biasing is 0.01, and you see how nicely it overlaps. It just so nice. And remember, when this only works when the biasing is less. If you have a high biasing, like biasing can be between 0 and 1, right? So suppose I give a biasing of 0.2, then nothing works. Like, you won't see anything. It is like pointless until and unless you have a small biasing. Only then it works well. So if I have this, let's say, even then it's very hard. I have to make it even smaller. But if I give it sufficiently small biasing, it works very nice. Even this is not enough apparently, but if I increase the trials, maybe something may happen. So okay, you can see it's matching very nice, very well, with just small values. If I decrease the biasing further, it is like perfect. It's so nicely matching. These two overlap very well. And I can increase the number of trials, of course, and you can see. So Poisson and binomial are almost equal to each other when I have very small biasing and large trials. I don't even need 6,000, 7,000. The moment I cross 1,000, it's now think in terms of atoms. In atoms, you have like it is crazy, freaking crazy. Like, in atoms, you have like 23 zeros, about 10, 23 zeros following this. So just think how accurate those partition functions and all those crazy machinery should be, because just simply because the numbers are too large. How much free we are, how much freedom we get to do all those approximations. So seeing these curves match was really one of the best things I can do today. It was really satisfying and it made me happy. So thank you for watching, whoever watching. So bye.